Okay. All right. So last time we focus on solving the system of linear equation, okay? And we be able to rewrite the system of linear equations in terms of the quotient matrix times the vector of unknown vector and equal to the right-hand side matrix, okay? And we reduce that just for the shorthand. So we write it out in terms of what we call the augmented matrix. The augmented matrix is just you take the quotient matrix and the right-hand side, okay? So you write it out in terms of this left box here is represent the quotient matrix. And the right-hand side vector is represented here, and the unknown are omitted. So we don't want to write it, but we know ourselves that what are unknowns that we want to solve for, okay? So we have augmented matrix. And we talk about three operators that will not change the solution of the system of equation. So the rule number one that you can swap any equation or you interchange the row, the meaning the same that you interchange the row of the matrix in the augmented matrix, okay? Number two, if you multiply some row by non-zero values, so you will get the solution does not change. And the third one is you can add or subtract any row, okay? Any row. The solution does not change. That we call, by using these three operators, is said that you have the equivalent system. The equivalent system is mean you have the same solution, okay? And I introduce you that there are certain type of matrix which I want to introduce to you. Is the first one is called identity matrix. Identity matrix is the matrix that has the number one along the diagonal. If we have the identity matrix, okay, as the coefficient, this means that we already have the solution, okay? Or if you have the other type, which is called the upper triangular matrix. So you will see that you have all this top corner and the bottom corner equal to 0. So this is called upper triangular matrix. In the other type is the lower triangular matrix is like this. So you have the element, the number, the values here is, but the one on the top of the corner here are zeros, all zeros. This one called the lower triangular matrix. And the other one, we put the prefix, we have the other word in front of it. We have the word unit. If we say unit, upper triangular matrix, it means we add one more feature, it means the element along the diagonal equal to 1, okay? Similarly for unit, lower triangular matrix. If we have unit, lower triangular matrix, it means we put the number 1 on the diagonal as well, okay? And today we will learn the method of solving the system of linear equation, which is called the Gaussian elimination method, okay? What is the Gaussian elimination method? It means that we start with matrix A times x equal to b. Normally, matrix A is the full matrix. It means Barry has zeros, okay? But if you have the structure, sometimes we call those matrix which has a certain matrix which has more zeros. We call it plus matrix. It has mean matrix that has more zeros. They have more structure than is so the sparse matrix is easier to solve, but originally, normally we have matrix A, which is the full matrix. Okay, and then we will try to use the 3 operator, swap the row, multiply any row by non-zero constant, add or subtract any 2 rows. Okay, so all those 3 operators will make the system equivalent. What we try to do is try to reduce the full matrix to some system which is called upper triangular matrix multiplied by U. Okay, and today I will show you the feature of matrix U. U is the upper triangular matrix like this. If you rewrite this upper triangular matrix, you will get the system like this. Okay. If you look at the system like this, you have, for this example, is x plus y plus z equal to 6. 2y plus 2z equal to 7. Write down. Or 10. I made a mistake. Okay. 10, okay, 10, and then z equal to 3. If you see this system, you can solve for x, y, and z easily because you originally you get the value of z. Z can be calculated easily for this particular problem because you have 1 z equal to 3. Even you have 2, you have 3, z equal to 3, you can find z easily. Once you know z, you plug it in, you can solve for y. You know z and y, you get x. So this is called the backward substitution, or in short, we call back substitution. You have back substitution. Now, let's see. We start by 2 by 2, okay? If we have upper triangular matrix. If you write out the equation, it is like u11 times x1, u12 times x2 equal to b1, u22 x2 equal to b2. So what will you get from this? You will use this last equation first. You will get that x2 is b2 over u22. Okay. Once you get x2, you can get x1. You plug in x2 here. You will solve for x1. So x1, u11 x1 equal to b1 minus u12 x2. So x1 is the whole thing divided by U11. Okay? So you get x2 and then you get x1. How about 3 by 3? You get U11, U12, U13. Okay? From this system of equation in the metric form, just rewrite this again in terms of the equation. Okay. Let me write down the one on the bottom first, because we know U33X3 equal to B3. So at this stage, you will be able to find X3. X3 is B3 divided by U32. And then you're done. Okay. Now, the second equation, you will get U22 times X2 plus U23 times X3 equal to B2. Since you know X3, okay, it means you know this term. You will move this term to the right. So X2 equal to B2 minus U23 X3. So I move this term to the right, extract, and then this is multiplied by U22. So I move that to the right, it's gonna be divided by U22, right? So you get X2. From the first equation, you get U11, X1, U12, X2, U13, X3 equal to B1. So you want to find X1. What do you know? You know this term, you know this term. So I will move these two terms to the right, okay? So you will get B1 minus U12 X2 plus U13 X3 divided by U11. Okay. Now I will do it n by n. Okay, n by n. And this will give us to see how when we want to do the programming. This is I show you that if we do it by hand, okay, systematic way, we do the one on the bottom, go up and up and up, okay. So now if we write this in terms of n equation, n unknown. Okay. Next equation is u2 to x2, u3 x3. Okay. Suppose we talk about K row. K row. What does it mean? It means the first element you start with, suppose I said I'm go down to row number, suppose n is 1000, okay? If I say row K now is row number 10, so you will get U10, 10, right? So if I talk about UK row, any row is mean UKK. Times the unknown K plus U row K column K plus 1 times X K plus 1, right? Plus U row K column K plus 2 times the unknown K plus 2 up to the U K N X N equal to B what? The K equation BK. Okay. So if you are at the n minus 1 row, you will have 2 unknown. Okay. You have 0, 0, 0. You have U n minus 1 n minus 1 x n minus 1 plus U n minus 1 n x n equal to b n minus 1. And the last row, so you have U n n x n equal to b n. Okay, it's no matter how large of the values of n. To find the last element is always what? X sub n is gonna be equal to b sub n divided by u n n. This is always the first step. Okay. For x n minus 1, it's gonna be b n minus 1. Subtract all the known values with u n minus 1 and x sub n divided by u n minus 1 n minus 1, right? Can you write down x sub n minus 2? It's gonna be b n minus 2. Subtract all the known values. So you can start by u n minus 2 divided by u n minus 2 n minus 2. Now I will focus on the row K. In order to find this xk, what does it mean? It means that we know all this thing. Everything up to this stage known, right? They are known from the previous step, previous calculation, because we got from the bottom, go up. Before you reach this row, all the bottom row give you all those values of x. Okay, so these are no. So okay, let me write down. Instead of write down in the long add so many terms, let's just write down in terms of the index. So we will say that at the row k, we have u k x k plus or the summation of u k fixed j I start from n go down to k minus 1, right? n minus 1, n minus 2, go down to k plus 1, I'm sorry. Or I will say that actually it's step down, k plus 1 to n. Okay, k plus 1 to n. And for this one, k start from n minus 1, n minus 2, and go down to 1. Right? If you guys are write the computer code, you start with n is 1000. You use the same algorithms until you get down to 1. Okay, so you will use the for loop. Okay, for loop. So you will say that okay. Oh, what else we have? Okay. Okay. So if I write down the pseudocode, I will say that pseudocode, we will say that okay. So we have to have input. So input, you have coefficient matrix A. Okay. A. We have right hand side vector B. We know the values of n. N is the size of the matrix. Actually, you don't need to input, but you can always find it. But here, I'm sorry, I use the index start from 1. Okay. But if you write in Python, index start from 0. Okay. But this one, I talk about pseudocode. Okay. If you do writing the code in Python or other languages, I'm the old people. I start learning the code by C++, and my advisor, he now 80 something, 89, okay, years old. From his work, he start from the punch card. Okay, it's the very old in the early days, and he used Fortran. So I use Fortran to write my code even now then I use Fortran, okay? But I also learn Python, and so that helps students doing important things. But yeah, I know it's very confusing when you go from one language to the other language in programming. But I would say that it just gives you the picture. The number is just a running number. So just try to just follow the number here. But if you write the program, it's different, okay? It is change the index. You make the index down by 1 because the array starts from 0 in Python. Okay, here input A, right hand side vector B, okay, and A I store it in the 2 array ij, okay, and I just use the let's see aij, okay, aij. What should I say is more? Okay, maybe I use AI, comma J is the member of matrix A, I row and J column, okay? Or maybe I use AI, comma J like this one, okay? Okay, I will try to use the element of matrix A is A, okay? Vector B, I write down as B1, B2, and so on. Okay, something like this. But we want the output vector x, right? What we want vector x, we will want to get x first row, x second row, x n row. This is what we want. So input here, instead of the dense matrix A, I will give instead of A. Since you have the pattern here as the upper triangular matrix, instead of using A, I use U. Okay, so instead of capital A, I use U. So what the algorithm is, we will have x sub n equal to right hand side a b sub n divided by u n n, right? And then for k start from n minus 1, step minus 1, go down to 1. Okay, you can think that you start, suppose n is 100, you get the last one, which is x 100 first. Then later on, you will use whatever here, the algorithm I will write down there to calculate 99, x 99, x 98, x 97, and so on up until 1, x1, okay? You go from here, you start from 3, you go down 2 to 1. Now you get to get back to 1. Okay, this is step down, backward substitution. Okay, so now since the algorithm is this one, let's see. You step down by -1. And then what you have to do, you're gonna have to find x sub k. Oops. X sub k. X sub k. Subtract by all of this summation. Then summation is sum from those point. Okay. So this one I should to use I. Row. Okay. Row I. Row. And then now I have to do this summation. If now focus on this one, the summation. If k equal to 88, suppose k equal to 88, what would you do? You will sum I equal to 89 to n. Suppose n is 100 to 100 of u 88, right? K is this one and I supposed to be K. Right? Okay. So you have to calculate U 88, 89, X 89 plus U 88, 90, X 90 plus U 88, 91, X 91 plus and so on plus U 88, 100, U 100. Okay, this is how you sum it. Okay. So when you do this one, how can you find the sum? If I want to do the sum, you have set summation equal to 0, right? And then for I start with 89, step plus 1 up to n. Sum equal to sum plus u ki xi, right? Okay, this is how we get the summation. So now, instead of this, add step k. So it's going to be k plus 1 up to n, right? Because now I'm row at 88, but for the general, suppose k is 88, you sum from 89. If k is 1, k is 1, you sum from 2 to 100, okay? So this is how we calculate the summation. So we start from I, step down to 1. Now we say sum. Oops. Right? UIKXK. And then what? XI. Okay. So this is how we do it. You get it? So we call this part as sum, right? We know how to calculate all the sum here. So we want to find x sub k. This one xi, okay? Let's see. I use index one. Rho k. Okay, I use the unknown here. K rho, no? K is the this one, okay, sorry. Because I said I look at the K row, okay? So XK, and then it doesn't matter actually, but don't want you guys to confuse. Equal to K plus 1, step 1 up to N. So it's gonna be U K I X I is sum. So now it's a XK. Going to be the K equation. Subtract by the summation you got from previous and divided by UKK. Yeah, so you were not confused. So this is called the back substitution. Okay. Similarly, if you have the matrix L, lower triangular matrix, that one gonna be easier. I should start from lower triangular matrix, okay, because it's forward substitution. Okay, so let me just give you the forward substitution. Okay, you have L11 X1 equal to B1. L2 2 1 x1 plus L2 x2 equal to B2. L3 x1 plus L3 x2 plus L3 x3 equal to B3. If you add the K row, you will have L K1 x1, L K2 x2, L K3 x3 plus blah 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 plus L K K x K equal to BK, right? Up to the end, L N1 x1, L N2 x2, L N3 x3 plus to the last one, L N N X N equal to B N. You have if you write down the quotient matrix is lower triangular matrix, okay? Okay, you have lower triangular matrix as the coefficients. So forward substitution, the first unknown, you can find it easily. So you have what? X1 is B1 divided by L11, right? Now for K, start from 2, step 1 up to N. You increase 2, 3, 4, 5, 6 up to N. You will have to find all the sum. Okay, before we go this one, let me just write down the general form for the K equation. So you're gonna have X sub K equal to what? It means that before you find out the last unknown xk, all this x1 you know, x2 you know, x3 you know, okay? So all of this you know. All of this you know. So it's gonna be bk, oops. bk minus the summation I from 1 to k minus 1 of L K I X I. The whole thing divided by L K K. Okay. So for this, it means for K equal to 2, step up 1, 2, 3, 4, 5 up to N. You calculate the sum. Sum start from 0. I start from what? 1. Step 1 to N. Right. 2K minus 1. Okay. Sum equal to sum plus what? L K I times X sub I. Okay. And then you will get that x sub k, the row k is bk minus sum divided by L k. Okay, so this is called the forward substitution. Okay, you keep doing this. Now, since we know that the structure of the matrix, if it's lower triangular matrix or upper triangular matrix, we have the algorithms, easy one, to find the solution. Do it repeatedly, okay? So the computer will do it. We write the program, we get how to do it. But now, the problem is, if we have the matrix A times X equal to B, how can we reduce this to matrix U X equal to the new right-hand side, okay? So if we start from here, we can use backward substitution, okay? But now the stage that from matrix A, how can we go to U, which do it systematically, okay? Suppose I have the matrix 2x plus 3y equal to 4 and equal to 5, like this. I will write down the augmented matrix, okay? I will have the matrix like 2, 3, 4, 3, 1, 5. Okay. I will give the name for the one in the corner. Okay, I will give it as the main values that I want to use, okay, to make the one, this matrix to be the lower triangular matrix. I call this one as the pivot element. Okay. And you use this pivot to make the one below the pivot equal to 0. It means if you want this to be 0, right, you can do it. I want it to be upper triangular matrix, it means you have this one. The one below have to be 0. Okay, you want to make it as the upper triangular matrix. I look at the pivot, and now I will try to make the element below the pivot element equal to 0. Okay, how can I make number 3 to be 0? Okay, number 3 to be 0. I will say that is equivalent by I will take row number 2 is replaced by, if I write this out this way, row number 2 subtract by, I want to get rid number 3, right? I will say whatever number 1, which is pivot element. Number 2, I divided the whole or multiply the first equation by 1/2. So I make this to be 1, okay? If I divide this by 2, it does not change the system, right? So I'm gonna divide it by number 2, okay? But if I divide it by number 2, this will be 1. This will be 1. If I divide this by 2, so R1 is R1 divided by 2, okay? But now it is 1. I want to multiply this by 3, right? So it's going to be 3. So if I have 1 here, I have 3 minus 3, it's going to be 0. Going to be 0. So I will multiply the first row by 3 times of row 1 and divide it by 2. Actually, I divided by 2, make it 1. I want number 3, I multiply by 3, which means I multiply row 1 by 3/2. Okay. So this one going to be 0. You will use the same row, the same formula for every column. Okay. So the second column you will have 1 minus 3/2 times 3, which is okay. The third column is 5 minus 3/2 times 4. Okay. Okay. So you get the upper triangular matrix. Okay. I just make it up, okay? But let's see. If we have this system, first step, write this down in terms of augmented matrix, okay? 4 minus 2, 8, 3, 4, minus 1, minus 1, 0, 8, and the right hand side is 2, 3, 2. The first row, I will not do anything. But now I copy down the first row. Okay. My pivot element is number 4. What I want is the number below 4 in the first column. I want it to be 0. Okay, I write down 0. So now I want row number 2. How can I make the first element, the first column of the second row equal to 0? It's going to be whatever the number is, okay? Subtract by something, which I will use row number 1. I will use the pivot element to do it. So R1. And also R3 subtract by something, making by the pivot element which is located in row 1. Okay? So row 1, you want it to be 1, you divide it by 4. You want negative 2, you multiply by negative 2. Row number 3, you want it to be 1, you divide it by 4. You want it equal to 8, you multiply by 8. Does make sense? Okay. And you use R2 plus 1 over 2 R1. R3 minus 2 R2. So you use this formula to do it. Okay. So it is 4 plus 0.5 times 3 is 5.5. 0 plus, so minus 0.5. 3 plus 1 over 2 times 2, 4. Okay. The second row, R3 is minus 1 minus 2 times 3. Eight minus 2 times minus 1 is 10. 2 minus 2 times 2 minus 2. Okay. So you use the row here to do the calculation. Now, we will go down to 2 by 2, right? Start from 3 by 3. We go down to 2 by 2. And then we do the same thing. We repeat the step. And now the pivot move to second row. Yes.
Minus 2 are
Yes, yes, R1, sorry. Thank you. Okay, it's R1. Now, okay, we want to make the element below the pivot element equal to 0. So what would it be? It's going to be R3 minus row number 2 divided by 5.5 what you want, you get -7, you multiply by -7. Okay, so this is what you're gonna get. So it's gonna be 10 plus 7 multiplied by negative 0.5 divided by 5.5 is then something 9.3696. Okay, I make 364. Okay. And then you get -2 minus plus 7 over 5.5 times 4. Okay. And then you get the upper triangular matrix. Does it make sense? If you have the matrix like this, and make this one non-zero, okay? Yes.
Actually, it's 3.9.
3.91.
Oh, it's, that
ครับ okay.
is positive now.
Oh, okay. All right, it's -2, okay? Right? It's negative because here is negative. It's not this one. It's 2. Okay, this -2 come from what? 2 minus 2 times 2. So you get -2. So it's -2 plus 7 divided by 5.5 times 4. Am I get it right? Yes or no? No? -2 plus I got the same. I got the 7.0909. ถูกไหมเดี๋ยวนะนี่ใช่ไหม 3.09 So let's see. This cell is 0 by U1 7, W1 minus 7 divided by the pivot 5.5 multiplied by 5.5, right? This makes 0. So this one you used 10 minus all the ratio here, minus 7 over 5.5 multiplied by minus 0.5. You get the new values here. And this is also the same thing. You get -2. Subtract by this ratio fixed, multiplied by 4, the green one. So you get this part. Okay. So yeah, I made a mistake. So if you have something like this, originally the system on the okay. Okay, you have something like this. Whatever number it is, let's see. You want this equivalent, okay? This is just something, okay? Just some number. So you want to get rid of this and this. How can you do it? Row 2, subtract by row 1 divided by the half, right? And you want it to be as this is multiplied by 8, okay? And how can I get rid of diamond? How can I make the diamond equal to 0? Row number 3. Subtract by row number 1. Make row number 1 equal to 1 divided by the half. And I want it equal to diamond. I multiply by diamond. So I can get the 0. And then this also apply by using the same, this one. If you want this one, you use the formula below, okay? So this is how we make it upper triangular matrix, okay? And then next Friday, we will come back and we start from the beginning. We have the system of linear equation. We reduce it to the upper triangular and we do the backward substitution to get the solution, okay? And I will see you guys next Friday. Okay, yeah. Have a good weekend.